Hello everyone, this is Rochan here. Today we are going to touch up on a small topic from the chapter Trigonometry. That is, we are going to geometrically prove cos of x plus y is equal to cos x cos y minus sin x sin y. How do we get this equation? We are going to see today. Right before starting the actual derivation, you need to have a prerequisite knowledge kind of. So for that, I'm going to explain a small concept. So let me consider this as the coordinate axis with x, y, x dash and y dash. X dash is the x axis, y dash is the y axis, and they're going to meet at the origin O, right? So now let me just take a point here in the form of p of x comma y, right? So this means that this distance is x and this distance is y, right? This is what it means. Now I am going to consider that a circle is moving through this point, right? Now, if a circle is moving through this point, then the center, let us call it origin itself. So the center of the circle and the origin of the coordinate axis, they meet at one point, they intersect, right? Now OP is going to be what? It is going to be the radius. Here, let me take specifically radius as 1 unit. So, I am considering a unit circle. Unit circle means a circle which has radius equal to 1 unit. It can be 1 centimeter, 1 meter, and anything as such, right? Now, let me call this angle as theta. This is y, right? This is x. This is going to be perpendicular. Now, if we apply the trigonometric function sine theta, it is going to be opposite by hypotenuse. We know this is 1 unit, right? Opposite by hypotenuse, y by 1, which is nothing but y. Next, cos theta is also going to be adjacent by hypotenuse, that is x by 1 is equal to x. So in place of x, I can put cos theta, and in place of y, I can put sin theta. So this point itself, p of x comma y, in place of x I can put cos theta, in place of y I can put sin theta. The same point can be written in this way if the radius of the circle is 1 unit. So using this concept, we are going to derive this cos of x plus y is cos x cos y minus sin x sin y. So let us begin with that. So here I have considered a circle. So consider a circle with unit radius, or consider a unit circle, right? And origin, sorry, and center at origin. So this is a unit circle, which means radius of the circle is 1 unit and center is intersecting or coinciding with the origin of the coordinate axis, right? So this is what we are going to consider, the first step. Next, let me take a point A here on the x-axis and on the circumference of the circle, right? We know that any point on the x-axis can be represented as a of x comma 0 because the y coordinate is 0. So here we know this is 1 unit. So a coordinates of a, I can write it as 1 comma 0, right? Next, let me take a point B here. I will take a point B and let me call this angle AOB as x. So angle AOB or BOA is x, right? This is my first step. Now, from the previous knowledge which I just explained before this, if we have some angle theta, the coordinates of B is say some x comma y, but I can represent the coordinates of B in terms of trigonometric functions as well. So what will be the coordinates of A we know is 1 comma 0. Of B, what can we write the coordinates of B as? I can write it as cos x comma sin x, because here theta is x, and in place of x coordinate I can write cos x, in place of y coordinate I can write sin x, right? This is about coordinates of B. Now let me consider another point C here. I'll join it with the origin. Let me call this angle to be y. Similarly, coordinates of C also we can find. But here one point to notice, this whole angle, what is it going to be? It is going to be the sum of this angle and this angle, basically x plus y. So in this case, theta for C is going to be x plus y, not only y. So coordinates of C can be cos of x plus y, comma sine of x plus y. In place of theta, here we have x plus y. That is all the difference. Next, now what I am going to do, I am going to take a point D here, and with D I am going to join O. D and O I am going to join, and let me call this angle as minus y. I am measuring it in the clockwise direction. That is why it is going to be, angle is going to be negative. Right? Now similarly coordinates of D can be cos of the theta minus y and sine of the theta, that is minus y. We have learned that cos of minus y is nothing but cos y. Cos of minus theta is cos theta. But sine of minus theta is going to be minus sine theta. So the coordinates of A, B, C and D is clear in these steps. Here, let me do another construction. I am going to join A and C. Let me join A and C. You can draw a straight line also like this, A and C. Okay. Now, we know the coordinates of all A, B, C, D. You just mention angle BOA is X, angle BOC is Y, and angle AOC. Totally, this angle is going to be X plus Y. And angle AOD, that is this angle, is minus y. If you observe carefully, triangle BOD and triangle AOC, they are going to be congruent. How? That you have to find out and let me know. So these two triangles are going to be congruent. We know that if two triangles are congruent by CPCTE, I can say AC is equal to BD. What is CPCTE? Corresponding parts of congruent triangles are equal. AC and BD are the corresponding parts of these two triangles, and I can equate them. Now, if I square them, even then they are going to be equal, right? So this is the first step here. Next, by distance formula, I am going to use distance formula. What will be AC if we use distance formula? We know the coordinates of A, we know the coordinates of C. So using distance formula, what is distance formula? Distance formula is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So using distance formula, AC is going to be root of cos of x plus y minus 1 the whole square, cos of x plus y minus 1 the whole square plus y2 minus y1, sine of x plus y minus 0 the whole square. I am going to ignore that minus 0 is equal to. So this is the distance of AC, but using 1 we have squared this, right? AC square is going to be this. Similarly, what is the distance of BD? We know the coordinates of BD. I will take cos x. So let me take cos x as x2 minus cos y the whole square, right? Plus sin x minus of minus sin y is going to give me plus sin y. Sin x plus sin y the whole square. and this is under root, and this is again squared, right? It is BD square. Now here square and square root gets cancelled. I am left with, let us split this. Cos x plus y minus 1 whole square is in the form a minus b whole square, and that is cos square x plus y plus 1 square minus 2 into ab. That is this, right? Similarly, sine of x plus y whole square is going to be sine square x plus y. On the RHS, we have to expand this and this. So let us expand using a minus b whole square and a plus b whole square formula respectively. So cos square x plus cos square y minus 2 cos x cos y plus sine square x plus sine square y, and here it is going to be plus 2 sin x and sin y. If you observe carefully, cos square x and sin square x is in the form sin square theta plus cos square theta. That is going to give you 1. Next, if you observe sin square y plus cos square y, similarly that is also going to give you 1. And you are left with, from these two terms, let me take minus 2 common. If I take minus 2 common, I'll be left with cos x cos y. To make it positive, I'll write minus sin x sin y. Right? So this is the RHS part. Now we'll come to LHS. Even here, if you observe carefully, sin square theta plus cos square theta will give you 1. You already have 1. So 1 plus 1. This term as it is, minus 2 cos of x plus y. Here also 1 plus 1, here also 1 plus 1 gets cancelled. Here also minus 2, here also minus 2 gets cancelled. So we are left with cos of x plus y is equal to cos x cos y minus sin x sin y. And this was the required equation, right? So this is how we derive this equation geometrically. I hope you have understood. Thank you.